This is Yasha Ben Israel, aka Terry Whitfield, for the Yasha Ben Israel Terry Whitfield podcast show, allowing y'all to come back with me again just to see all of these sources that we have about information about the E1B1B and the E1B1A being the original bloodline, you know what I'm saying, of the original Jews. Okay. I did an article earlier that showed an article earlier on the video I just did. Excuse me, I have the hiccups. But excuse me, I have an article earlier that I just did in the video that I just showed how the E1B1B is the major bloodline that they're looking for to determine whether you're Jewish or not, along with the J2, the J1, and the R1B1B, I believe. But I want to just show y'all how it may seem complex, but it just understand that it's simple how they really do this thing with genetics. All of these terms here, they got many different terms, many different words, many different numbers and letters to actually represent the same thing. Like, say, for instance, the EB3 was what they used to call it 15 years ago. That's what they first called it. Now, through the advancement of studies, and they learning a little bit more intricacies about how this thing works. They're coming up with other names, they're retiring old names, and all of this has to do with the new understanding. But it also has a lot to do with them hiding information. You understand what I'm saying? Because the EB3 is the basis for all of this stuff. Let's look into this article right here. This is where I posted it, and this is the focus, the main reason why I posted it. It says the EM215 and the EM35 are quite common amongst Afro-Asiatic speakers. The linguistic groups are carriers of EM35 lineage, have a high probability to have arisen and dispersed together from the Afro-Asiatic Urhamite amongst populations with the Afro-Asiatic speaking people. Okay. The history and the language basically is what they're saying is going together. The Afro-Asiatic speaking history, the people, the language. A significant portion of Jewish male lineages are EM35. I repeat, a significant portion of the Jewish males are EM35. Haplogroup EM35, which accounts for approximately 18% and 20% of Ashkenazis and 8% to 30% of the Sephardi chromosomes, appear to be one of the major founding lineages of the Jewish population. You really have to understand history to understand what they're saying. Basically, what they're basically telling you here is that the E1B1 gene, okay, is a major Afro-Asiatic gene, and it is accountable inside of 20% of the Ashkenazi population. Now, that does not mean that it is accountable out of 100% of the population. It's not saying that only 20% of that populace have this gene, the EM215 and the EM35. They're not saying that. What they're saying is that 20% of the whole genome, the whole populace, the Jewish populace, they're saying that, like, say, for instance, one person, they could take one person, and they're saying 20% of his genes go back to these African genes, which are the EM215 and the EM35, which is none other than the E1B1A and the E1B1B. Let's go take a look at this. Okay. The EM215, also known as the E1B1B, the E1B1B, and formerly the EB3. The EB3 gene was a gene that's the gene that I carry. I'm the E1B1B. Okay. It says that the E1B, the EM215, also known as the E1B1B, and formerly the EB3. Remember how I just told y'all just earlier how that's all it is. This is what, and you won't find, and a lot of people who have like stopped following genetics and the study of genetics, and then they come like me. I was really, really hot on the subject of genetics, and I stopped following it for years. And I'm hearing all of these people talk about the E1B1A, the E1B1B, the J1, the J2s, and I'm like, okay. And what is happening is that, and I'm like, but what about the EB3? You know, they don't talk about that no more because you see where it say that it's formally because they retired the EB3. The EB3 today is most commonly known as the EM215. EM215. Also known as the E1B1B. You'll hear most Jews and most African Americans talking about the E1B1B. Or the E1B1A, which is the other group, okay? It is a major human Y chromosome DNA haplogroup. It's a major group. It is a division of the microhaplogroup EM96. So you talk about the SNPs, the SNPs. That's what I call it. When you hear me talk about the SNPs, I'm talking about the SNPs. The SNPs it deals with how genes break off and mutate. Okay? Let's look into this EM96. Let's see what we got going on here. These East African and Eurasian genes. It's very hard for geneticists to pinpoint, and they just can't say it. All of the evidence seems that the way that you look at the genes and how there's a mass populace of the E1B1A and just the E groups, period, all throughout the Western Africa and the Congo. And the reason why it's hard, you know, for geneticists to understand how this thing is working because most of the people that carry this gene is in Africa. Okay, and that's just the facts. That's just the reality. But they can't say that Africa is the home of that gene because they don't have enough genetic material, ancient genetic material, to substantiate that claim. You know, they say it's due to a lot of the climate, the super hot climate and just the overall conditions of the tropic regions, at large. Oh boy, I'm getting sleepy here. I just spent a lot of time doing. Uh, remember I was telling you all about the SNP. That's the SNP. You see right there, the SNP. Okay, where it talk about it is a division of the microgroup E196, which is defined by the single nucleotide polymorphism. It's kind of like when the genes snap off. It's a good acronym that they use. SNAP. Okay, it's the 215. In other words, it is the major paternal lineages of humanity, linking from father to son back to a common male line ancestor. It is the Y chromosomal Adam gene. It is a subject of discussion and study of genetics as well as genetic genealogy. Yeah, I was just pretty much looking into here. I always look down through here to see if I can find something real easy that I can just tap on that really explains all of this in a nutshell. You see this is littered, You know, the EM35 is littered with information to let you know that it's called the E1B1. Right here, where you can see where it's also estimated that EM78 called E1B1. Oh boy, that's hard to read. E1B1B1A1 in that paper. You got the E1B1A and you got the E1B1A1. Okay. Has been in Europe longer than 10,000 years. Wow. That validates how Europe was created by black people, and how the Phoenicians carried those E1 genes, those E genes too. And just talk about how the Phoenicians go back well over 10,000 years. Go back long like that. It shows you how, and their ancestors, go back way that far. I mean, this stuff just show how this gene go way back before Noah's flood and all of that stuff. And this the mindset that you have to have when you're looking at this type of information. You just can't start pinpointing stuff. You have to really look at what you're dealing with here. 10,000 years is a very, very long time for that gene to have been around. But the earth is long. Israel itself is not that long. But this shows you how that gene that created Israel has been on the planet for a long, long, long time. Let's see right here. It said accordingly human remains. I'm going to pull it up so you can see right there where I'm at. Now scrolling down from there. It says accordingly human remains excavated in a Spanish funeral cave dating from approximately 7,000 years ago were shown to be in this group. So this shows you that this group has always been known to run back and forth throughout Africa and throughout Spain, way before Spain was ever heard of, well before Tyre was ever heard of, well before Tarshish was ever heard of, well before Canaan was ever heard of, well before Israel was ever heard of. These people were common to that whole particular reason. And this is why I tell people that names of people have changed. You understand? Names of people have changed. But the genes don't change. People, what they call themselves, always change, but the genes don't change, That's how I think about Sinetta when he asked the apostle the other day. He asked them, and he was talking about genes, aren't you all what your father are? And he was talking about Esau and things of that nature, but aren't you all what your father are? And he was asking them, dealing with Esau, was Esau's father an Israelite? And the apostle said no. And he asked them, isn't he is what his father is? And that's a trick question because he is what his father is. But his father was not an Israelite, his brother was. And he is not the same as his brother is, even though his brother is the same as his father and he is the same as his father, yet and still his brother, they're two different people and they're breaking off into two different snaps. They're breaking off into, two different snaps to make it simple. Their bloodline is related and it should be related, but eventually they're going to, the genomes is going to mutate and snap off into something else. And when you look at history, you can see all of this. You can see all of this. You can see where Shoshank, there's cartouches in Spain of Pharaoh Shoshank, going back way before King Taharka. And this here exemplifies to us how there was Egyptian, the E1, they are the E1B1B as well. And it shows you how this genome has been all the way into that land. Africa, the Levant, you know what I'm saying, Spain, the Mediterranean. Those areas is the areas that we come from. We don't come from Africa. We come from that whole old world. Okay? The world was here before us. So we can't lay claim to certain parts of the world. You know what I'm saying? The world was here before us and the world created us. We didn't create the world. I seen some interesting information on this page as I was talking. Okay, I want to go back to that. I got to go back to that. But I'm looking on here. What was that I had seen on here? Oh, okay, right here where it says, I'm gonna scroll up to the top. Now scroll down right there. Excuse me. According to Lazaridis et al. 216, Neptufian skeletal remains from the ancient Levant predominantly carried the Y-DNA haplogroup, the E1B1B, as well as the Jews. We see that. So we see that the Jews and the Israelites had the same haplogroup. Okay? And there's no surprise to how King Hiram was a half-breed where I think his father was Canaanite and Jewish and his mother was straight Jewish, or his father was Canaanite and his mother was Jewish. But they still, fortunately, they had the same gene pool. You're talking about the Natufians. How the Natufian skeletal remains from the ancient Levant predominantly carry the Y-DNA haplogroup E1B1B. Of the 5 Natufian specimens analyzed for paternal lineage, 3 belong to the E1B1, B1, B2. Oh my goodness, I can't read that. That's so goddamn hard. But y'all get where we coming from here. And then, I mean, it's basically telling you, and look at this right here. This telling you what I said right here. Additionally, haplogroup E1, B1, B1. Okay, E1B1B is Jewish. E1B1B1 has been found in ancient Egyptian mummy excavations at Abusir el Malik, archaeological site in the Middle East, Egypt, Egypt, that's Middle East, which dates from the period between the new kingdom and the Roman area. Fossils at the Ibero-Maurasian, that's like in the Spanish area of Spain. You talk about Iberia and the area of the Moors, Carthage, Tunisia, Morocco, Ibero-Moor, Morocco and Maurasian. You're talking about the Afro-Asiatic world. A site of Afra in Amor or Moussa in Morocco. See, remember I was telling you Tunisia, Morocco, that particular area, which have been dated to around 5,000 BC, also carry haplotypes related to the E1B1, B1B1A, the the EM81 subclade. These ancient individuals bore a orthodox Maghribi genomic component. That's the Maghreb, Western Africa. And it's the Maghreb is the Morocco, Algeria, the north, all of the north and the western part of Africa, all the way down to the Congo, the Sahara Desert, all of that is the Maghreb. Liberia, Tunisia, Morocco, Algeria, the Cameroon, all of the western head of Africa, all the way to western coast, all the way down to the Cameroons, actually. This gene goes all the way down through there. And it's been going down through there for years. They talk about the Maghrebi genomic component that peaks amongst the modern North Africans. This thing was a Maghrebi thing. The Maghreb is the sub-Saharan Africa. And how it peaked up in the northern parts of Africa, indicating that they were ancestral to populations in the area, meaning that the people from sub-Saharan Africa were the ancestors to the people of the north. The E1B1B haplogroup has likewise been observed in ancient Gauche fossils excavated in Gran Canaria and in the Tenerife on the Canary Islands, which have been radiocarbon dated to be between the 10th and the 11th century. Now those would have to be people that were scrambling around, creating what they call the Bantu expansion, which was none other than people running from the Levant into the Maghreb during the time of more so the Babylonian and Assyrians. You know, the Assyrians go back before the 7th century. In fact, the 7th century was the Neo-Assyrian Empire. That was the last. You know, the New Jacks that popped up on the scene. The old Assyrian Empire was all black. Okay? So, yeah, we getting off into this, and I just thank y'all for spending the last 20 minutes with me. I'm just going through some information down here, you know. I'm going to talk about, you know, I just want to speak on this stuff. The scientists found that 5 male specimens with sufficient nuclear DNA preservations belong to the E1B1B1A1, the M78 subclass. This stuff is interesting, y'all. I thank y'all for coming on this journey with me. Time to let y'all go.